All right, so in this system of equations, we have these two equations together. I think this was problem 12 on your worksheet. When we just straight add them, it'll be 0 plus 0 equals 0. That's your first sign that all of these cancel out. So that's when you're like, that's weird. That's suspicious. Okay, so 1, they all canceled out. Cancel? What? That's weird. That's suspicious. So you look closely and you're like, these look kind of the same. They just have different negative or positive symbols in front of them. So, you know what? I'm gonna make these two things match. So, I'm gonna multiply this by a negative sign and then do distributive property to everything because you can't just do one thing to one side and not the other. And so I would get negative times negative is positive 2x, negative times negative y, positive y, negative times negative 10, or negative times positive 10 would equal negative 10. What? This bottom equation is basically literally the top equation. So, like I mentioned earlier, in the system of equations, you have obviously a graph that looks like this. Maybe, probably, it would have little like lines for like 1, 2, 3, -1, -2, 1, 2, blah, 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 blah. It would keep going on forever, right? Let's say this is not going to be an accurate graphing of the equation. Since we figured out that both of these equations are the same equation, that would mean that when you graph it, let's say this is the line on the graph for this bottom or top equation, the top equation. But wait, we basically figured out that they're the same equation. So both of these equations would just be on top of each other. And that would mean that any point on this line is an answer for both of the equations, which would give you infinitely many solutions. Yeah, it's basically because they're the same line, so that's when you get infinitely many. And let's say you do the whole thing, but eventually you get something that doesn't make sense, like let's say at the bottom you got 0 equals 5. That is not a true statement. 0 does not equal 5. And you're like, oh no, did I like mess up? So you go back, you redo your work, and you still get 0 equals 5. And you're like, well, oh, okay. I can't seem to find the solution, and this is not a true statement. So there's no solution. And if we look at a graph, an example of a no solution in a systems of equation would, I believe, it would be parallel lines, because, you know, when you pick a point on this one, you would get an x and y value. You plug it in. Well, you look at that. It works for this line, but that point never touches that line. So it's never gonna be true for that line. And that's where you get the 0 equals 5. And obviously that's not true. It's because you have parallel lines. Or maybe your equations are much harder and you have like some funky looking graphs. Sometimes they're like, they go like this. They never touch. So a solution for this line won't necessarily work for this one because look, they're two different points. So that's where you get no solution. And your first clue for that should be the random not true statements where it says one thing equals another thing and it's not true.